Hello and welcome to today's SEI webcast, Top 5 Considerations Before Boarding the Container Ship. I'm Aaron Volkmann. I'm a DevSecOps engineer at Software Engineering Institute. I'm focused on modernizing space systems out in the Denver, Colorado area. And today I'm joined by Dave Shepard. Dave, why don't you introduce yourself and your role at the SEI?
Hi, I'm David Shepard. I work for the Software Engineering Institute with the DevSecOps Innovations Group, and today we're here to talk to you about containers.
We will make our discussion here as interactive as possible, so we want to address any questions you have throughout today's talk. You can submit any questions you have in the chat area, and we'll do as many as we can. So to kick things off, why don't we talk about, like SOA and cloud. Containers are one of those brand new buzzwords that everybody's talking about in tech, and a lot of organizations are super eager to, engage there. But we want to make sure that we're aware of the business conditions and make sure that by adopting containers, you're really looking to solve a particular business problem that you have.
Yeah, absolutely. So, the business considerations are probably the most important considerations when you're working with containers. You should definitely, if your problem is related to deployment of software, delivery of software, containers might be a good solution for the challenges you're facing.
One of the big motivations that I've seen with customers that I deal with, we're DevSecOps engineers. We're helping organizations create pipelines, and they want to achieve continuous delivery of business value to their customers. And if you think about needing to achieve something like a functional test of an application where we deploy the application into an operational like state, and we have automated tests that act like functional users interacting with that application. We have all the tooling that we need to do something like this, with VMs. Imagine an on-prem solution, and we wanted a functional test environment for VMs. We'd have to get involved with scripting, doing VMware orchestration through scripting in order to spin up a new VM, install infrastructure as code tools to that VM, to install software dependencies, install our test harnesses into that application, and deploy the application and run our functional tests. So that's a pretty heavy lift. Wherein containers, they provide us a lot of the packaging and tooling that makes this much easier. And by containerizing, a lot of that heavy lifting of deployment and automation is intrinsic to that tool set.
Yeah, for sure. But the way you deliver software changes dramatically because now all of that stuff has to be built into your containers, your configurations, and all your dependencies.
David, we had a question that came across the YouTube channel. Can we define what we mean by a container? I think in this context, we're mainly talking about application containers. Care to,
Yeah, sure. So
explain what we mean?
definitely we're talking about application containers. Containers is a technology that we typically associate with Linux, and it is the actual name for it is LXC, which is Linux containers. What it is it's a set of lightweight abstractions that wrap around a process or a set of processes that present themselves as a lightweight virtual machine, right? It's not good to call them virtual machines, but that's the closest comparison because it kind of presents itself to the process as being everything that you need to run your processes, your applications, like a machine would do, but it's isolated from all the other processes, at least from its own view of what's running on the system. And it's different from a virtual machine because it doesn't actually emulate hardware like you see with a virtual machine. So the container presents itself in a way that is like a machine, but really really lightweight and has a lot of good properties for the cloud and things like that, which we're going to get into a little bit later in the talk.
Yeah, one of the way I explain it to folks, whenever we're running, a series of containers on a given host, if we're a user with enough privileges, we can issue for on Linux, we can issue a ps -ef command and view all the processes that are running inside of our containers on the host operating system. It's not like a virtual machine where that memory space is encapsulated in containers. The memory addressing is segmented off namespacing. Really, those applications inside a container are really, really running in the kernel on the host operating system.
Yeah, it's a distinctly different way of deploying software than a virtual machine because you don't actually have to emulate a whole host OS for it to work. You just run the processes that you need to run for your application.
And I'd say that that's one of the big advantages on what, if I'm a business, why I might want to go to application containers. We deal a lot in classified environments where, we're dealing with applications that aren't traditionally connected to the internet. And if our unit of currency for deploying applications is VMs, that the file size of a VM image can become prohibitive to achieve continuous delivery of updates, where we're transporting around VMs that can be 30, 80, 100 gigabytes, where containers are often much smaller size on disk. So transporting them around can be much more easily accomplished.
Hey, Aaron, can we take this question from Paul on the chat?
Yeah, sure. Compare and contrast
So, Paul,
batch files. Yeah. Go ahead, David.
compare and contrast batch files, scripts, and containers. Besides Nix operating systems, what other operating systems support containers? So let's start with the second half of that question. Containers are an inherently Nix operating system technology. When you see containers running on other operating systems, whether it's Windows, Mac OS, or something else, it's usually through an emulation layer. On Mac OS, for example, if you're using Docker for Mac or a product like that, you're actually running a virtual machine that runs a Linux OS that then runs the container, it hides all of that from you if you're using Docker for Mac, but that's how it works. On Windows, if you're using the Windows subsystem for Linux, it's actually doing something similar, although Microsoft has made a substantial investment in actually making containers run very well through sort of a really lightweight virtual machine that's kind of tied to the host pretty tightly. For the first part, batch files, scripts, container. Batch files and scripts. So usually if we're talking about batch files, we're talking about a form of a script. A script would be as a small piece of code that executes some series of operations, right? And we typically use those in the container world to build containers via normal tools like you would have in a Unix environment. Like you're building your container, so you run a set of commands like installing software and copying files over to the container, things like that.
And just to follow on with comments on is this a Linux thing only? There are native Windows containers now. I would say that it's slightly emerging technology. A lot of our customers are not yet there yet, but I've seen, containers running PowerShell things in them, and the technology is available natively on Windows now, Docker specifically. I think one of the other advantages of that containers bring to us is it can save us money on cloud costs because it allows us to achieve a much more dense deployment, meaning I could be deploying multiple independently deployable units, often with conflicting dependencies in a container, where in the past, say we need specific versions of third-party libraries installed at the OS level. Those are encapsulated by the container, so we could have different versions of those living side by side on a given container platform host, all living concurrently. If you think about paying your cloud bill per instance, we can achieve a much greater deployment density with containers. And with everything, there's advantages and disadvantages and trade-offs when deploying in that style.
Hey, Aaron, do we want to get into Chris Zamora's question on chat yet?
With all hype around containers, I'd like to hear when it's best not to use containers at some point. Yeah, that's the topic, the main topic, and we can go ahead and slide into that, particularly from a cybersecurity aspect, I think, Dave.
Yeah, so containers ultimately they're like any other technology. They have an ideal set of problems that they are suited for. I'd say anywhere that you are working with something where you need a guarantee of data privacy or a guarantee that you are running in a isolated environment where nothing else is in that environment with you. That would be a situation where you might want to consider something besides a container, because a container doesn't know anything about the environment in which it's operating in, and it has almost no assurances of data privacy from a host process with proper privileges. So, you should definitely consider your application domain of what you're trying to implement for that sort of thing. There's also, a lot of people think that containers are not capable of doing graphical processing. That's actually not the case. They can do graphical processing just like any other process running on your host, but if you're going to use them that way, there is some extra configuration that typically needs to happen to make that work. Also, I think I should probably say that there are different types of container implementations, even on Unix systems. There's a number of container-based technologies that are based on LXC that operate and provide different functionalities. For example, was it Ubuntu's package format, Snap, is actually a LXC container format that is actually more tightly coupled with the host OS than a typical, say, Docker container. So it actually provides a different type of functionality set.
I'd also say that adopting container technology, it's one of those things where you achieve through frequent deployments and frequent packaging, we achieve economies of scale where there's an upfront cost to within your organization building that capability. Containers require new tool sets, a whole new swath of artifact management needed, vulnerability scanning, staff training. But if our goal in life is to deploy changes to our applications very, very frequently, then we'll achieve those economies of scale. So perhaps if we're in a mode where, for whatever reason, we're deploying very, very infrequently. Perhaps containers is not, worth that lift.
Hey, Aaron, do we want to talk about containers versus microservices a bit here?
Yeah, sure. I think a container architecture, lends itself very well to microservices, and you might want to, uh, they might be considered synonymous with each other because by default, containers, you know, by default, that tooling wants to run only one process in it. So by its very nature, it encourages a microservice type architecture. Um,
Yeah, it certainly enables the design of microservice meshes. So, but you still have to think about the way you build your application in order to have it operate as a series of cooperating microservices, even if they're just even deployed in containers, right? So there's you don't have to deploy microservices in your service mesh as containers, but the containers do help by enabling that sort of architecture.
I think it goes back to my point on economies of scale. Once we're in microservice architecture, the advantage of microservices is, we gain the flexibility to um, update and change, test, and deploy different components of our system versus a monolithic application, which its deployment testing time, would be much, much longer. But um, the uh, the advantage of the advantage of running that in containers is that the you know if we're in containers, we're packaging our applications such that they're deployable, and it lends itself to achieving uh, having the machinery needed to uh, update, maintain, and deploy many, many small applications in the form of microservices.
Yeah, so they're pretty convenient for developers. You can spin up entire stacks of infrastructure for all of your different pieces of your application and run them side by side in isolation of each other and without affecting your development environment. You can even easily swap out different versions of your services in your microservices architecture, and just to try different things. In fact, we do that a lot in various sorts of deployments.
We have a question on the line. Can we discuss the use of containers for continuous integration, continuous delivery? Whenever if any of our viewers are working with the DoD, there's a big push towards centralizing the knowledge base of DevSecOps, CI/CD pipelines, and the push is to uh, compose our DevSecOps pipeline with a series of tools that themselves are containerized. So it's important to note that our pipeline tools, meaning source code repository, continuous integration, server, um, cybersecurity, functional testing tools, artifact repositories, all of those tools can be containerized themselves. In addition to that, there's also the subject of containerizing the payloads flowing through the DevSecOps pipeline and what that means. Um, and at the basic level, I think it means during the build phase, build, unit test, functional test, deploy, scan phase, our applications are containerized during the build phase and stored at the end in an artifact repository in its containerized form and versioned at that point.
So, Aaron, the question on chat here about how do you manage shared state with containers? Uh, I'm going to call it persistent state, shared persistent state, just to clarify a little bit. So, shared state is persistent state is a database of a various type. There's different types of for different needs, you're going to need different types of persistence, but the way you manage it in a container isn't that much different from the way you would manage it in a traditional application architecture. Your persistence mechanism, if you use a database or whatever you're using for your persistence, it still needs to be able to write to a file and save that data somewhere, right? So, or if it's an in-memory sort of thing, it needs to be able to access that and share it to other processes that need access to it. Containers, we should probably talk a little bit about immutability, Aaron, but the technology, when we talk about containers, we typically say that they're immutable and their state can't be changed. That's actually not the case, but you do have to configure their runtime environment so that they can manage state properly.
Yeah, so to summarize, the way we save state is we can mount in disk. Going back to immutability, by default, our container, the file system inside of the container, once the container stops running, that any changes to the file system goes away. If the exception to that is if we mount persistent volumes into our container. That would be things, if we were running a database in a container, that would be, we would mount in volume file systems, directory paths, where our data would be persisted on either the container platform host or some other network storage for it to be mounted in. Any other persistence that can survive between container executions would have to be stored somewhere outside of the container, either through another service and a service call, or through that file system. The immutability aspect. Oh, I'm sorry. Go ahead, Dave.
No, I was just going to say that unlike the virtualization technologies that came before containers, one of the recommendations specifically with respect to databases was that you may not want to virtualize them, and that was because of the way that virtual machines work. Virtual machines, because they emulate hardware, you actually take an I/O hit on the number of operations that you can perform on your database server through a virtual machine. And it was on the order of like 5%. That performance hit should be negligible with containers due to the improved, we're going to call it density. Use I/O density, memory density, all of these different things. Because of the way containers work, fundamentally they are more efficient for the host to run them.
We have a question from Chris. He asks, will we containerize our state storage? Say we had a database and we had to mount in volumes for its data directories. Would we containerize any of that stuff, David? I'm speaking to the persistent storage itself.
Yeah, so you persistent storage in a container. It kind of depends on how you're running your containers. You have to get that storage into the container somehow, right? Whether it's it's a copy on write file system, or it's some sort of mount in a Kubernetes or something like that. There's a lot of storage is kind of a deep topic. There's a lot of different ways we could go with this, but yeah, I guess I would say that your particular needs for what you're trying to do is going to dictate how you're going to implement that storage in your container.
Yeah, for the most part, if we're without some very complex use case that would require a proxy or a pass-through to our storage that would be facilitated through a container, generally speaking, you would not containerize the storage itself. that your containers would have that persistent storage mounted into it. I have a question on the line, regarding security. I think it goes to whenever we're talking about, or compared to VMs, if we're talking from the context of the host operating system running our container platform, what's going on inside the container is very observable from the outside, from that host operating system. And we have a question. Does it mean that it's not good when you don't have control over the host if we're running on a cloud provider? I think absolutely. Or are we talking about all circumstances? And I'm thinking that means if we're running a container platform on an on-premise solution, do we have the same cybersecurity concerns regarding the observability of what's going on inside the container? David, what do you think about that?
Yeah, so security is another deep topic, one that we can definitely talk about here, though. So, there's a couple different ways to look at this puzzle, right? So, with the virtual machines, we had a situation where anything running in the virtual machine had pretty good isolation from other processes, and it had decent controls over its ability to have private data. Still not perfect, but because of the machine emulation, it was much harder to break through that abstraction and actually see what the machine was doing. On the other hand, that's kind of a two-sided coin, because observability is actually one of the key benefits of containers, right? So if you're more concerned about knowing what's going on inside your containers as opposed to the container's ability to hide information and protect its data, that's a completely different property, right? So it kind of depends on, like I said before, like your application and what you're trying to solve. If you're less concerned with your application's ability to protect and safeguard its own data, and you're more concerned with your ability to observe what's going on within that application, then that's when containers would have valuable properties for your security domain.
So let's shift gears slightly, and this is sort of a security related topic, but let's talk about not literally Patch Tuesday, but Patch Tuesday in that, in a traditional deployment mechanism, the responsibility for patching the operating system and updating third-party libraries, often due to cybersecurity concerns. In the past, that was the responsibility of sysadmins, and being taken care of by that crowd. In the containerized world, with the third-party dependencies being inside that container, it requires updating third-party dependencies for a Patch Tuesday type event. That requires a release of a container, meaning bumping a version number, going through testing of our applications, and deploying updates to our applications themselves in containerized form, versus a traditional scenario where our applications would be deployed out there on our servers, and then a sysadmin team would come in and perform those updates to the host operating systems.
Yeah, for sure. It changes the way you manage your deployments and your software drastically, because once that software is inside a container, all of the dependencies are packaged with it, which has really nice properties for us for stability and our ability to guarantee the behavior of our application. But now you own those dependencies as they are packaged with your application, which, in a technical sense, you probably owned them before that, but maybe the management of those things was at a different place. Instead of being maybe in the scope of your developers, it might have been in the scope of the ops team that actually managed the application's runtime.
So I'd say adopting application containers and needing to update our applications perhaps more frequently in the past. I think it lends itself and as a justification for adopting a DevSecOps methodology where we have the tooling in place, the automated testing in place in order to confidently release new versions of our containers, much more rapidly than before.
Yeah, so DevOps, DevSecOps, it all fits in nicely with this ecosystem of containers and microservice architectures and in-house deployments of software. All of these things sort of fit together, and the reason for that is because the containers are an enabling technology for all of these different things.
We have a question from the YouTube channel. Is it mostly worth using containers when you own the apps? Or should containers be used with, should we be wrapping our own COTS products, containerizing COTS products, that we're running? What do you think about that, Dave?
I think there's cases for both COTS products. I find myself working more and more with open source products, but I have ran things like Oracle database in a container. It can be done. There are some considerations to think about, though, if you're going to do that. Oracle in particular is a pretty heavy product.
Right. So, in my experience, we're rolling DevSecOps pipelines wherein we're relying on a continuous integration, continuous delivery pipeline in order to fulfill our packaging of deployable units, cybersecurity scanning, functional testing, and such. So that lends itself very well to getting to a state where our unit of currency in the pipeline is a containerized application. So even if so I found myself, seeking to containerize applications where the vendor does not provide a container because that's what my infrastructure, my development and test infrastructure is set up for, and it's much easier to deal with once we achieve the economies of scale. Much more easy to deal with a containerized application. We have a Kubernetes cluster as our container platform in production, with the monitoring, logging set up for doing that with containers. If we would add an oddball into the mix and have a COTS or a FOSS product that we would have to deploy as a VM in that mix, then that sets a point of variation where for many organizations, the goal might be to shift towards containerizing everything in a given environment, so that you have that deployment similarity and can take advantage of that tooling. We have a question out there. How would you?
Question.
Oh yeah.
Go ahead, Aaron.
No. If we compare the difference in size between an application deployed in a VM versus a container, I don't know. I think it depends what we're talking about, but a container ends up being much, much, much smaller. On the realm of tens to hundreds of megs versus gigabytes for a virtual machine. Has that been your experience as well, Dave?
Yeah, the container, if you build them right, they literally only have the footprint of the software necessary to run your application processes. There is literally nothing else on the container if you build them right. But there is lots of potential to not build them right? So you can put a whole bunch of stuff on there that isn't actually necessary to run your application, And then if you do that, it's not going to be a lot different, and you're going to miss some of the benefits of the containers over a traditional deployment.
Okay. Let's see. I think we covered, how responsibilities shift amongst our software teams. When we talk about sidecar containers and that concept and how they can, you know, either improve or lower our security posture. Um, there's a concept of sidecar containers wherein, the classic example that I can think of, a really simple example is for every application that we deploy into production, along with it comes a sidecar container that, let's say, hijacks the logs of our actual application container and forwards those logs into a log aggregator like I don't know, a Fluent D or an Elk stack or something like that. Well, what that allows us to do is it can shift the responsibility of configuring that logging through the container by updating the sidecar container instead of updating our application container, so that changes to that logging could occur with the deployment frequency of an infrastructure type thing instead of a business domain application type thing. Many organizations, in order to release a new version of the application itself, would require a much longer testing and acceptance period versus deploying a sidecar container that's responsible only for logging.
Yeah, so containers with sidecars, they present a lot of different things, like, for example, logging. You can also completely change behaviors for the application's runtime environment that maybe the application itself wasn't designed to handle. For example, working behind a proxy server or dealing with specific routing rules or protocols. The sidecars can adapt a lot of things like logging and networking and routing and other types of concerns of that type, and actually adapt your applications and your containers to operate in ways that they were never originally designed for.
For instance, if we're talking about service mesh sidecar container, the way the applications are configured inside of the application container, if they need to perform egress or talk to a service outside of that container, the application itself could be configured to speak to localhost, and the service mesh sidecar container would have the responsibility of intercepting that traffic and forwarding it on, and that configuration would actually live within the sidecar. You have a question out on the web about any advice on how to improve our security using containers and what direction should we look. I think there's a suite of security tools. We have to, whenever we're just like anything else, if we're consuming containers from vendors, containerized vendor apps, just like in a traditional deployment, we should perform cybersecurity scanning activities on that and be aware of updates in that ecosystem. You have any other general tips? I know security hardening within the container still is still a thing that does not go away, and that we should be aware of you know the all the components and the composition of the container, looking for malicious binaries, that kind of thing.
Yeah, so security scanning, you generally have two very distinctly different types of security scanning when you're looking at containers. You have your traditional application scanners, which they could be static scans of the runtime They might even have source code available to them to give you feedback about the application itself and how the code quality is and how it's written and stuff like that. And then there's another category of scanning that you can do with containers specifically, where you actually look at the installed base of dependencies and look to basically see if there's any known vulnerabilities out for those dependencies and whether there is a solution for them or not. And the different types of tools will give you different types of reporting capabilities for the application as it's built, the runtime status of the security of the application, and the security of the dependencies for that application, based on what's known out there from open source security databases.
Robert Bernstein had the question, has decoupling applications from common dependencies via containerization been a problem? I'm not quite sure what the context of the question is. Are we talking through microservices where in the past, certain dependencies might be living side by side, but once we containerize, all of a sudden those two components have to speak over a virtual network? Maybe some clarification of the nature of that question.
Yeah. So for the dependencies, it really comes down to how you build your containers. If your process for building your container has to put all of your development tools onto the container in order to build it, you should probably then remove those tools at the end of your build process. And we can do that today with a two-stage container build, which will allow you to basically build the container with all of the development tools that you need it. And then you take as a second step, just pull in the pieces of the container that you actually need to deploy. So that's one way to help with that decoupling of I'll call them initial dependencies that were necessary to get the container.
Yeah, I've seen it's very desirable to achieve build inside of a container. And just to restate, pile on to what David said, we'd have a container with our compiler in it, mount in the source code, conduct the build of that application inside of that container so that we would have a binary of our application. And then it would not, then moving on to another container that would be for testing and deployment, we would build a second container around that, which would contain the bare minimum needed to run that container in operations.
Yeah, I hope that answers that question.
Yeah. We speak to container security applications. We're not really looking to recommend any specific tools, but we speak about container security tools in a very general sense. We recommend any strategies for what kind of solutions should be deployed and how and when. David, do you want to take a swing at that question?
Yeah, so everybody has different needs for their security posture, right? Some people are just looking to get a quick picture of, have I done anything glaringly bad, right? Can we catch those sorts of things? And then other deployment scenarios really need to know that they've nailed down every last possible security concern or have mitigated it in some way. So it really kind of depends on what you're trying to achieve. Yeah, there are some products out there that will help you with this in the holistic sense and sort of try to provide every capability for you. Those are some good tools. There are also some good open source tools, but you're typically going to have to do more of the work yourself with the open source tools, and you can you can combine them all and get much of the same effects, but you're definitely going to own more of that process if you do it that way.
Yeah, I would think, for any organization that I support, I'd recommend that at a minimum, you initially, whenever we're bringing in containers, have something that can introspect the contents of the container and do an origin analysis of binaries in the container to identify common uh, CVDs and common vulnerabilities inside of the container, so that we're aware of those things and are able to build up the capability to understand the contents of these containers and maintain a catalog of all the binaries that we're bringing into our organization from a security perspective.
So, Aaron, the question about performance issues.
Yeah,
I think performance is an area where containers typically shine when compared with other virtualization technologies. One of the things that goes right along with performance is density, right? Aaron, do you want to talk a little bit about density?
yeah. So we talked about it a little bit before in terms of density. Containers allow us to deploy many, uh, many more instances of applications onto a given virtual or physical host. Uh, Allows us to have fewer virtual machines in general. Let's see, as far as we're talking about, it can also decrease density in terms of the amount of CPU compared to a virtual machine. For instance, for running a bunch of virtual machines on a virtual host, um, each one of those virtual machines is emulating the network hardware, uh, the network cards on each of those virtual machines. And that kind of compute density, is more heavyweight compared to the software defined networks in a container,
So,
because we're not emulating that hardware.
yeah, so part of the issue with the density thing in performance is, for example, in a virtual machine, if you have a system with 16 cores and you want to utilize 16 of those cores, you have to tell the virtual machine it has 16 cores to use. With container, it just uses what's available. A big part of the performance equation is effectively using the resources that you have available to you. So instead of dedicating a specific chunk of physical system memory, say 8 or 16 gigabytes for your application, and saying this is your memory, you simply use the amount of memory that's available to you with a container, and you use that efficiently, which means that you can effectively get more applications running in that same memory space with your container deployment than you could with a traditional virtual machine. So effective use of resources, whether it's networking or memory or CPU, um, and the lack of some of the translation overhead and the type of problems that you would typically have seen in the past with virtual machines, containers tend to stack up very well against other technologies in that regard.
I think where containers may decrease performance, if we compare a monolithic application where different processes inside our monolith are able to communicate with each other in memory and via calls on the system stack, that's doable within a monolith. But if we're re-architecting our system to communicate via microservices, each the inter-process communication can then shifts to occurring either via the file system or most often over the network. so we can see a performance decrease there and have to account for those through our system architecture. I think if we're talking about cloud native applications, two different processes that are communicating with each other, won't necessarily exist on the same physical machine. So that inherently changes the way that these processes talk to, but often, shifting those communications to be over the network, taking on the overhead that comes along with that.
Yeah, but you gain a lot of flexibility in the way your software is deployed when you re-architect it that way.
Right, we gain that. As we said, we're dealing with a federation. We're deploying, updating, changing, testing many small things, as opposed to dealing with very few very large things, which lends itself very well to a DevSecOps methodology and gives us that flexibility.
So, Aaron, you want to take any of these other questions on here?
Let's see. Maybe we're recommending any specific books and support software for computer science courses involving containers. I think maybe this is, I don't know if I have any recommendations offhand. Maybe this is a question that we can take offline in the YouTube channel. Do you have any recommendations, David?
Yeah, so containers themselves, if you want to understand the base technology, definitely, take a look at like Docker's documentation. They do a really good job of explaining the different architectures, but you can also, all of these vendors, Microsoft, Amazon, they all have tremendous resources on how containers work and how you should use them. If you want to take a real deep dive, you're eventually going to start looking at Linux kernel documentation, which there's a lot of documentation on the actual APIs that are used and how the various abstractions come together to create the illusion of a machine for the processes that are running on it. But as far as specific books and courses, yeah, I think that's probably a take it offline sort of thing.
So we're going to talk about a little bit about staff training and what we can expect as far as the lift needed to get our staff up to speed on adopting container technology. I think maybe one of the biggest differences that depending on how your team's organized is it shifts left a lot of the operational concerns, where the application developer who's responsible for writing my Docker file will have to gain much more knowledge of the Linux operating system and the deployment environment. Where in the past that might not be true depending on your organization.
Yeah, there's definitely going to be some upfront costs to training and retraining and hiring, depending on the scope of your application and how much work you're going to have to do, whether it's a new application or whether it's a rewrite of an existing application. You can even take pieces of your application and move them at a little bit at a time. There's actually a name for that. It's an architectural pattern that's typically used in the cloud. Remember what that's called, Aaron?
Oh, we talking the Strangler pattern?
Yeah, that's it, the Strangler pattern. It sounds ominous, but really what it just means is isolating small pieces of your application at a time until you can chunk away at what is your traditional monolith application and start migrating that into a more microservice and separated application deployment.
Yeah, so in this, real simply in the Strangler pattern, if we're we would, let's say we have a monolithic application, and the Strangler pattern would involve deploying a new containerized component of the monolith that would sit next to the monolith. We'd reconfigure or redeploy the monolith so that it would take advantage of the new functionality that's provided by the container, and then sunset that piece of functionality from the monolith. And that's how we incrementally deploy containers next to our monolith in a way and port functionality from the monolith over to the containerized instances of that functionality piece by piece until the monolith can be finally sunsetted. Bob Bender has a question about what approach to version management is useful for containerized systems. I'm not sure what the context of the question is exactly. I'd recommend using semantic versioning of the containers so that breaking changes to updates in the containers can be communicated and expressed, and that the versions of yep.
Aaron, I'll take this one a little bit. So
Yeah, go ahead.
when you're talking about version control with containers, you could be thinking of two different things. Actually versioning the artifact, which is the built container, and for that we typically use what do we call them? We call them a registry, where you basically store tagged versions of your containers that will be used across the environment. There's also version control of the sources that built that container, which you should definitely do, and you should be able to tie back the actual build artifact of the container to the source that built that container. So we use at least two different parts of the version control of the container itself.
Yeah, I think and that becomes from a DevSecOps perspective, storing your container images in a container registry, having them versioned, and maintaining the traceability between the build artifacts at the end of our pipeline, traced all the way back through to our issue tracker that catalogs the changes that are made to those containers, is of the utmost importance, because at deploy time, we're deploying immutable containers, and it increases there's not as much sysadmin wiggle room for hand jamming or manipulation of those things once they're deployed. So I think one of the skill sets or capabilities that container technology calls for is the ability to be very confident in what we're deploying.
Aaron, I suspect we've got time for one more question here.
Do you have a favorite one, David? Do you want to pick out?
Not particularly. I was going to let you do that.
I think we did I think we hit them all here. Does anybody have any other questions to help close us out? I guess I wanted to close with some comments on Kubernetes, which is a close follow-on to the discussion of application containers. Kubernetes was developed by Google to allow applications to be highly available in a cloud-based deployment, wherein at any given time, any physical host in a cloud provider, there are no guarantees that a given host or a network path will be available at any given time. And Kubernetes seeks to provide the tooling that we need to deploy our applications in a highly available fashion. And there's a huge push in certain circles to adopt Kubernetes, and it gives us tremendous advantages and capabilities. But along with it comes a pretty steep learning curve, a pretty steep cost if we're going with a commercial solution. So I'd recommend taking a really good hard look at your organization's requirements, especially if we're dealing with on-premise solutions on, how do we best adopt a container orchestration technology like Kubernetes, just because it has substantial upfront cost in terms of training and licensing costs, depending if we go open source or a commercial solution.
Yeah, it's a very powerful technology and one that we could probably talk about for a long time by itself.
Yeah. Is it time for class? Is it time for beer containers? Uh, yeah, 5 o'clock can never come early enough. And there's always those Zoom happy hours at the end of the day, so that we can enjoy some refreshments.
What do you say, Aaron? You want to take one more question, or are we done here?
Are there any other questions out there? Data management,
Got one
data
on.
engineering realm folks. Yeah, go ahead, Dave.
I was just going to read. In data management, data engineering realm, while we have seen much of the containerization kicking in with data transfer services, any insight to practices evolving in the rest of the landscape? I'm not entirely sure I know where to take that question. I think I would need more information. Sorry.
Yeah, that's I'm not too tightly. I haven't worked in that kind of business domain to let you know what the state of the art and what folks are doing there, unfortunately.
All right, Aaron. I think we're out of questions. So.
All right. Well, I'll go ahead and close it up. Thank you for attending today. Please join us for next week's webcast, which will be hosted by SEI CTO Tom Longstaff and Jeff Bowling, Senior Advisor for Software Acquisition from Undersecretary of Defense for Acquisition and Sustainment at United States Department of Defense. You'll all be emailed since you signed up. We'll all be emailed with the registration link to tune into that next one. Any questions stemming from today's event, please send any questions to info@sei.cmu.edu. Thanks so much for tuning in, and we'll see you next time.